This is the 11.6 section presentation where we learn how to find the volume of prisms and cylinders. So the solids we're going to focus on in this section are just prisms and cylinders. So volume, what is volume? Mathematically, when I think of volume, all I think about is the amount of stuff I can put inside of a solid. It's kind of like three-dimensional area. Area, if you remember, we do in square units, like base times height. Volume, we have base times height, but we also have a width or a third dimension to it. So really, it's kind of like area for solids. The formulas we're going to focus on just in this presentation are volume for prisms and volume for cylinders. And even though the formulas look different, I really want you to think of these formulas as the same, because basically all you have to do is find the area of the base, whether it's a prism or a cylinder, and then multiply that number times the height, and that's going to give you the volume. So for a prism, it's usually base times height. For a cylinder, it is pi r squared. So the volume of a circle, which is what the base is going to be of a cylinder, is pi r squared. And just take that number and multiply it times the height. So if you think of the volume in this case as basically being the same formula as area of the base times height, it's going to be really easy for you to do these calculations. So let's take a look at an example here. So here I've got a hexahedron or a cube or a prism. And what I want to do is I want to calculate the area of the base. So the base is going to be 4 by 4. So it's 4 units here, and it's 4 units here, and then the height is 4 units. So it's going to be 4 times 4 times 4. So the area of the base is 4 times 4, which is 16 units squared. And then I'm going to multiply that times 4. So 16 times 4 is 64. And then our units for volume are going to be cubic units. And when we write cubic units, we just have a little power of 3 that we add to units. So this is 64 units cubed. All right, let's try to find the volume of this particular figure. So again, we want to find the area of the base. The area of the base here is going to be 10 times 4, which is going to be 40. And then my height is going to be 6. So I'm going to take 40 times 6 and get 240. Now, one of my concerns when students are writing answers to this is that they're going to go 240 inches, and then they're going to go cubed. And what this looks like is 240 to the 113th power. So this is not something you can do. You can't abbreviate inches when you're writing units like this. So you're going to actually have to at least abbreviate the word inches as IN. So that's pretty much the least amount of work you can do. And this will be 240 cubic inches. So again, don't abbreviate inches or feet whenever you're calculating volume with just like the little hash marks. You're going to have to either write inches or IN, or if you're writing feet, you can do like FT for feet. Okay, so we want to find the volume of this isosceles trapezoidal prism. So we got to find the area of the trapezoid first. So area of a trapezoid is average of the bases times the height. So don't confuse base as being like the bottom part of this solid here, okay? My base is actually going to be what really kind of looks like the front. So the base is actually going to be here, and then the other base is going to be here, because the faces have to match. So if I made the bottom rectangle a base, then I'd have faces of rectangles and trapezoids, and you can't do that. Like the faces have to match like at least the same like style of polygon. So average of the bases times height. So the bottom base here is 14 of this trapezoid. The top part is 6. So this is going to be the average of 6 and 14 added together. And 6 and 14 added together is actually 20. 20 divided by 2 is 10, and 10 times 3 is 30. So 30 centimeters squared is actually the area of this trapezoid. And then the height, you just multiply it times 5. So 30 times 5 is going to be 150. And then because the units are centimeters, it's going to be cubic centimeters or centimeters cubed. So the volume of this particular figure is 150 cubic centimeters. Let's take a look at this one. So our base here is going to be our circle, and we already have the radius at 11 feet. So this is going to be pi r squared. My radius is 11. 11 squared is 121. So the area of my base is going to be 121 pi. And then I just take that number and multiply it times 6. So 121 times 6 is 726 pi feet cubed. And then I guess if you don't want to keep it in terms of pi, you can multiply it times pi, and you're going to get 2,280.8 cubic feet. Okay, basically the same deal here, except the 40 feet here is actually the diameter. So the diameter of this solid is 40 feet. So my radius is going to be 20. So when I calculate the area of the base here, it's going to be 20 squared times pi. And 20 times 20 is 400. So the area of my base here is 400 pi feet squared. And then I just take that number and multiply it times 10 because that's my height. And that's going to give me 4,000 pi feet cubed. And I can multiply that times 3.14 to get 12,566.4 feet cubed or cubic feet, depending on how you want to say that. All right, ooh, a fun one here. So I want to find the volume of this solid. And what I've got basically here is I've got this purple solid, this cylinder here, and then there's a part of it that's cut out. So apparently I drilled into this solid. Not sure when I did that, but apparently I did and made a hole inside of this solid, and I want to figure out the volume that I've got remaining. So first thing I want to do is find the volume of the regular cylinder. So my radius is 8, so 8 squared is going to be 64. So 64 pi is going to be the volume of my, or going to be the area of my base. And then I'm going to multiply that times 14 for my height to get the actual volume of the entire cylinder. And that's 896 pi cubic centimeters. Now I do the same thing with this small one here. So my radius is 2. So that's going to be 4 squared is going to be, 4 pi, or 2 squared is going to be 4, and 4 pi is going to be the area of my base here. And then I multiply that times 14. So 4 times 14 is going to be 56, not my best mathematical deal there. 4 times 14, 28, it's going to be 56 pi centimeters cubed. And then all I need to do is subtract those two numbers. So I take 896 and I subtract 56, and that's going to give me 840 pi centimeters cubed. And then if I want to multiply that out, I just take 840 times 3.14 pi, and I get 2,638.9 cubic centimeters. All right, Cavalari's principle, okay? So Cavalieri actually did a lot of mathematical work, but one of the most important things that he came up with is that if I have two solids that have the same height, and if I slice them across the middle at some point, and they've got the same area at that point, they're going to have the same volume, even if they're not the same kind of solid. So you'll look here, we're comparing a couple of pyramids here, but they're not even the same shape pyramid. So if you've got the same area when you slice it across and you create that area, even if they're not the same solid, they're going to have the same volume. And where this comes into play is when we're going to be dealing with oblique solids. So these are tilty solids. When we are calculating volume of tilty solids, what we care about is the actual height, not the slant height, the actual physical height. So I'm going to show you how that works in the next example. So in this case here, I want to find the volume of this tilty solid. So same deal with volume. I find the area of my base first. So I have 4 centimeters as a radius here. So 4 squared is going to be 16. Okay. So the area of my base here is going to be 16 pi centimeters squared. And then when I try to figure out the volume, I've got two choices. Do I multiply it times the tilty height of 10, or do I times it by the actual height of 9? And according to Cavalari's principle, I'm going to treat this as the physical height. So not the tilty height, the physical height, like how much literally it takes for me to get from the bottom to the top. So I take this number and multiply that times 9, not times 10, but times 9. And I get 144 pi cubic centimeters, and I can multiply that out by getting rid of the pi and be left with 452.4 cubic centimeters. So that's the deal with Cavalari's principle. All right, so that brings us to our assignment. So for Monday, I want you to do page 754 to 755, just problems 1 through 10. Hold on to them, don't send them to me. Wait until Tuesday when you do questions 11 and 12 and 15, and then 18 through 20. And when you're done with Tuesday's assignment, then send both of those assignments to me in an email. And I hope you found this presentation helpful. Thank you.